Okay, this is the Year 1 book, exercise 13, mixed exercise, and it's question 18 on integration. Now, we are dealing with a problem here with quite a few bits to do. The first thing is that we have to find the value of P and Q basically, or show that P is minus 7. Now, we're given the equation of the straight line and we're given the equation of the curve, and we know that at A and B the values of x are 4 and 8. So we're going to use that to form two simultaneous equations in P and Q to find them. Okay, so let's make a start on that now. So for part A, okay, the first thing I'm going to do is set the two equations equal to each other, because that's what happens where the two lines intersect. So I'm going to set P plus 10x minus x squared equal to the straight line, which is qx plus 25. Okay, now I'm going to change all that around and put everything on one side and turn it into a quadratic with a 0 on the other side. So I've got x squared. Okay, I'm taking all this to the other side. I've got x squared minus 10x minus p, okay, plus qx plus 25 equals 0. Okay, if I now just gather together the sort of different powers of x, so I've got my x squared there, I've got q minus 10 lots of x, okay, and I've also got the constant, which is made up of plus 25 minus p, okay, and that has to equal 0. Now I can now take the two known values of x to make two equations in P and Q. So at A we know that x equals 4, so I'm just going to write here x equals 4, okay, implies that, substituting 4 into here, 16 plus, well, if I multiply this out as I go, it's 4q minus 40, okay, substituting x for 4, plus 25 minus p equals 0. Okay, now if I just work on that and tidy it up, I get that p minus 4q equals 1. All right, now I do a similar thing when x is 8, because that's the other place where we know the curve crosses the straight line. So when x equals 8, I get 64 plus 8q minus 80 plus 25 minus p equals 0. If I tidy that one up, I get another equation connecting p and q, this time that p minus 8q equals 9. All right, now if I subtract those equations from each other to eliminate p, if I call that equation 1 and this one equation 2, okay, if I do equation 1 take away equation 2, that gives me that 4q equals -8. And therefore q equals -2. Okay, so I found the value of q, which is part of my answer, so I just highlight that there. All right. And now I found the value of q, I can substitute into one of the two equations. So I'm going to substitute q equals -2 into, well, it doesn't matter which one, let's substitute it into equation 1, and that will give us p minus 4 lots of -2, so it's p plus 8 equals 1. Therefore p must equal -7 as required, because we had to show that p was -7 in the question. Okay, and that kind of confirms then that q is right as well. So let's just highlight that, and that's the answer to part A. Okay, now we go on to part B, and we've got to calculate the coordinates of C. Now, if this is a horizontal line, we know it goes through A, and we know that there's another place where it crosses the curve at C, which has the same y coordinate as A. But at the moment, we don't know what the y coordinate of A is. So let's find that out. So I'm going to put B here. In fact, I think I'll start question B up here. So for question B, okay, this is at the point A. So let A equal the point 4, y. All right, we don't know what y is yet. We're going to find out. Now, if we take the equation for the curve, okay, we can say that -7, right? So that's p plus 10x, which is 40, minus x squared, which is 16, equals y. Okay, and if you tidy that up, you'll find that that equals 17. Okay, so we know that A is the point 4, 17. All right, 417, that's supposed to say. Right. Okay, so we know that the y coordinate of C is also 17 because it's a horizontal line. So, but we need the x coordinate. So at C, let's say here at C, okay, y equals 17. Okay, implies that p, so it's -7 plus 10x minus x squared equals 17. Okay, so I've just substituted the 17 for y into the equation for the curve. All right, going to rearrange that to make hopefully a friendly quadratic that will easily factorize, which it does. So it gives me that x squared, okay, minus 10x plus 24 equals 0, which gives me that x minus 4 times x minus 6 equals 0, okay, which means that x equals 4 or x equals 6. Now, of course, we know x equals 4 because that was point A. So therefore C must be when x equals 6. Okay, so therefore C equals 6, 17. Okay, now for part C of the question, we have to, I'll just highlight that. So for part C, we have to now use the information we've gathered so far, and by using algebraic integration, find the area under that, in that shaded region there. Okay, so I'm just going to call that area there R, capital R. Okay, and we know that the area R is going to be the integral between 4 and 6 of the curve minus the rectangle that's sitting directly beneath it. Okay, if I just draw the rectangle on, you can safely say, without much working out, that that is an area of 2 times 17, okay, which is 34. Okay, so I'm going to say that the region required is equal to the integral between 6 and 4 of -7 plus 10x minus x squared with respect to x minus the area of the rectangle, which I'm just going to write as 2 times 17 here. All right. Right, well, if we integrate that, we get, don't forget we need the square brackets, we need minus 7x, we need to raise the power by 1 and divide, so it's 10x squared over 2, which is 5x squared, and we've got x cubed over 3 there, no constant because it's a definite integral, and now we've got to substitute our two values in, which are 6 and 4, and of course we've got to subtract our 34 from that as well. Okay, when we put the values in, that's going to give us, well, minus 7 times 6, it's going to be minus 42, plus 5 lots of 6 squared, which is 180, take away 216 over 3. Okay, and then from all of that we've got to subtract the same thing again, except with 4 in, which is minus 28. Okay, then we've got 5 lots of 4 squared, which is 80, and then we've got to take away 64 over 3, and we've got to take away from all of that the minus 34. Okay, now put all that on your calculator, work it out, it comes to 4/3. Okay, and that is the area under the graph between A and C and the top of the curve, with the rectangle removed because of the minus 34 at the end. Okay, and that is the complete solution to that question. Just a note of warning, it does say using algebraic integration and showing all your working, you have to show sufficient steps to justify those 6 marks. All right, we've done the algebraic integration, we've shown the substitution. It's acceptable at this point to put that on the calculator and evaluate it, because you've done all the integration by algebraic methods. Okay,